All right, on tonight's episode of Python Papi, we're back inside our artificial intelligence course, and we're still going over our learning module. Let's see what we went over tonight. Now, last night, if you recall, we started the process of going over our threshold function, and tonight we're going to build on top of that. So if we go back to this instance here, where we have rainy days on the right side of the line and not rainy days on the left side of the line, let's imagine we have two white dots, and we'll look at those two data points now. So if you see, this is our original model. We have our line that separates our rainy days, represented by the O's, and our not rainy days, represented by X's. If you look here, you see you have a W here and a W here. Those are going to be the two data points that we're discussing. We would like to predict a label or category for these two data points, the white dots. It seems likely that we could pretty confidently say that the data point to the far right is going to be a rainy day. It seems close to the other rainy days if we're going by the nearest neighbor strategy. And if we're using the line strategy of just which side of the line does it fall on, which side of the decision boundary, we would also say that the data point to the left is also going to be a rainy day because of its position on the decision line. But it's likely that even in this case, we don't feel nearly as confident about this data point on the left compared to the data point on the right. For the data point on the right, we can feel very confident that yes, it's a rainy day. The data point to the left is pretty close to the line if we're judging by distance, and so we might be less sure. But our threshold function doesn't allow for a notion of less sure or more sure about something. It's what we call a hard threshold. Once we cross the threshold line, then immediately we say, yes, this is going to be a rainy day. Anywhere before we cross the threshold line, we are going to say that it's not a rainy day. That may not be helpful in a number of cases. One, this is not a particularly easy function to deal with. And as we get deeper into the world of machine learning and are trying to do things like taking derivatives of these curves with this type of function makes things challenging. But the other challenge is that we don't really have any notion of gradation between things. We don't have a notion of, yes, this is a very strong belief that it is going to be a rainy day, as opposed to it's likely than not that it's going to be a raining day, but maybe we're not totally sure about that either. So what we can do by taking advantage of a technique known as logistical regression is, instead of using the hard threshold type of function, we can use instead a logistical function, something we might call a soft threshold. So let me give you a look at that now. So this will be our soft threshold here. As you can see, this was supposed to be a curve, but I am using VS Code, so we don't really have a curving feature here that I couldn't curve it, so I curved the best I could. But if you compare this soft threshold to our hard threshold, you can see we have a lot more wiggle room. So what our hard threshold here, anything to the right is going to automatically be a rainy day. There is no wiggle room. As soon as you cross the line, it's a rainy day. And anything before this line is going to be a dry day or not rainy day. As you can see, we don't have any wiggle room. And that's what our hard threshold. So we go back down to our soft threshold, we can see at least we do have some kind of gradation where it gradually changes over time. It doesn't just immediately change from a not rainy day to a rainy day. And that's basically what we went over tonight. And I'm not going to go deeper into everything that we did, but yeah, that was the basics of tonight. And again, I will keep you posted every step of the way. But for now, this is the Python Papi. You guys stay Gucci.